Welcome to the Mathematics in my channel. In this video, we are going to evaluate another interesting integral. So, this is the question. Okay, first of all, here arctan of. Now, I am going to divide both numerator and denominator by 1 plus x to the n, square root of 1 plus x to the n. So, we can write now this is equal to here 1 plus here square root of 1 minus x to the n over 1 plus x to the n over here 1 minus the square root of 1 minus x to the n over 1 plus x to the n dx. Okay, then we know this property, this equation of arctan of x plus arctan of y is equal to arctan of x plus y over 1 minus xy. Okay, then here we can apply this formula. So we can write here this is equal to integral from 0 to 1. Now instead of 1 here arctan of 1, so we can write arctan of 1 plus arctan of, now instead of y we have the square root of 1 minus x to the n over 1 plus x to the n dx. Okay, then we know arctan of 1 is equal to pi over 4. So here 0 to 1 pi over 4 plus, then we know also this property 2 times arctan of x is equal to arc cosine of 1 minus x square over 1 plus x square. Now I am going to apply this formula. So we can write here now we have arctan, but here 2, so 1 half times arc cosine of now 1 minus x square, so 1 minus, now instead of x we have this angle, so we can write 1 minus x to the n over 1 plus x to the n over here 1 plus 1 minus x to the n over 1 plus x to the n here dx. Okay, then we can simplify here 0 to 1 pi over 4 plus 1 half arc cosine of, now here if we take common denominator we know 1 plus x to the n get cancelled, here 1 plus x to the n minus 1 then plus x to the n, so 2 times x to the n, but here 1 plus x to the n plus 1 minus x to the n, so 2, so we know 2 get cancelled and here we have x to the n dx. Okay, then we can split our integral into two different integrals, and at the same time we can write pi over 4 is a constant, so outside of the integral sign, and here dx we know x, so 0 to 1 then plus 1 half times integral from 0 to 1. Now here arc cosine of x to the n, now we can integrate by parts. So as a first function I am going to take arc cosine of x to the n times here d derivative, sorry, integration of 1, so here x. Okay, then now here if we apply limit, here we have only pi over 4, so pi over 4 plus, now here we have 1 half, so 1 half times, now product of these two functions, so x times arc cosine of x to the n from 0 to 1, then minus integral from 0 to 1 now rewrite this function, so here x, then derivative of arc cosine of, sorry, now derivative of arc cosine of x to the n, we know here minus, so here plus 1 over the square root of 1 minus x square, so x to the 2 times n, and according to chain rule we should multiply by derivative of x to the n, we know general power rule, so n times x to the n minus 1 dx. Okay, then we can still simplify. Here we can write pi over 4. We know if we apply limit 1 and 0, this is equal to 0. Arc cosine of 1 0, here 0, so here 0. And now here we have sorry, here 1/2, so here also 1/2. Now here n over 2 is a common factor, so n over 2 integral from 0 to 1. Now here x to the n minus 1, so x get cancelled, and here we have x to the n over 1 minus x to the 2n, here is square root dx. Okay, now to evaluate this integral, I am going to take a substitution. So if we take here x to the 2n, so x raised to the 2n is equal to t. Now differentiate, so 2n times x to the 2n minus 1 dx is equal to dt. Then here x we know, t raised to the 1 over 2n power, so we can write here 2n times t to the 2n minus 1 over 2n power dx is equal to dt. Okay, then we can plug in here, so pi over 4 plus n over 2, limit also boundaries we know 0 to 1. Now here x to the n, x we know t to the 1 over 2n, so x to the n we know t to the 1/2, so here t to the 1/2 power over 1 minus x to the 2n we know t. Now dx we know dt over 2n times t raised to the 2n minus 1 power over 2n. Okay, then we can write this is equal to pi over 4 plus, now we know this n get cancelled, here 2, so 1 over 4 integral from 0 to 1. Now we can simplify, so t to the 1/2 minus 2n minus 1 over 2n power times 1 minus t to the, instead of square root of 1 minus t, we can write in the numerator 1 minus t to the minus 1/2 power dt. Okay, then here pi over 4 plus 1 over 4 integral from 0 to 1. Now if we simplify this, here n minus 2n, so minus n plus 1, so 1 minus n over 2 times n times 1 minus t to the minus 1/2 dt. Okay, then now here we can write this is equal to pi over 4 plus 1 over 4 integral from 0 to 1. Now I am going to rearrange this power like n plus 1 over 2 times n minus 1 times 1 minus t to the minus 1/2, we can write 1/2 minus 1, 1/2 minus 1 dt. Okay, then we know about beta function, so this is the formula 0 to 1 t to the x minus 1 times 1 minus t to the y minus 1 dt is equal to beta of x y. Also we know the relation between beta function and gamma function, beta of xy is equal to gamma of x gamma of y over gamma of x plus y. So we can write here pi over 4 plus 1 over 4. This is equal to beta of n plus 1 over 2n comma 1 half. Now we can write this beta function by using gamma function. So we can write here pi over 4 plus 1 over 4 gamma of n plus 1 over 2 times n gamma of 1 half over here gamma of sum of n plus 1 over 2n and 1 half, we know 2n plus 1, 2, so 2n plus 1 over 2 times n. Okay, then we know gamma of 1 half, the value of gamma of 1 half we know the square root of pi. So we can write this is equal to pi over 4 plus the square root of pi over 4 times gamma of n plus 1 over 2n over gamma of 2n plus 1 over 2 times n. Okay, this is the answer. If you like this video, please subscribe this channel. Thank you for watching.